we're going to get started here. We're moving into some of the Chapter 5 material. Last week, we had 2 sessions that we spent on factoring, and we're going to use quite a bit of factoring as we work in Chapter 5. So we're going to deal with a lot of rational expressions, and the word rational, hold here for a second, the word rational, pick a color that's going to show up. Has the root ratio, which is a fancy word of saying fraction. That's all these things are. We're going to have some fractions. So the root word for rational is ratio. And several things that we're going to do with our rational expressions. But the first thing that we're going to do is simplify them. We're just going to evaluate these expressions. And so I've pulled a problem here out of Alex that says that we're going to evaluate this rational function. And anytime you see evaluate, you should be expecting to get an actual number for an answer on these. Work through this one, and then I'll let you give one a try. But anytime I see this notation, this is called function notation, and it says that our argument function of variable x, and below it, they've replaced the x with a numerical value, in this case is 6. So evaluate rational expressions is we simply plug in or substitute in the value 6 everywhere that we see the variable x. So I see 4 locations where we'll use substitution, and I always use parentheses when I substitute in my values. I'm going to do this right here. Anywhere I see an x, I'm going to use parentheses and substitute in the value 6. Copy down exactly as you see it. And we're substituting in the number. Down in the denominator at the bottom, we'll plug or substitute in the value 6. Just like, and what we have now is an order of operations problem. And you remember that we're governed in order of operations by this rule, PIM dot. Oop, happened to you, Christine. I'll try that happening. But this rule of PIM dot, and that just kind of a little bit of a guide to simplifying our problems. So I don't see any parentheses in the problem that have an operation inside of them. I have parentheses, but they're just isolating the value we substituted. But we're really starting here on the exponents. And so evaluating the exponents, numerator 6 squared is really just 36. I like to do it at a time, and next to my problem. So 9 times 6, I'm just using parentheses to show the multiplication. And 8. And denominator, we get 36. And then problem. And you think you got this. Certainly you can work through more than one step at a time. This is just how I started off teaching order of operations to students, and I just kind of stuck with it. It kind of became a habit for me. We come to the M, and it's the M and the D together. There's really 6 words up here, but it's only in 4 steps. So multiplication and division go together, and we do them from the left to the right. So in the numerator, we have negative 9 times 6. That's going to give us a negative 54. Use one more line in here. So that leaves us with 36 minus 4 plus. And if you hear any noise in the background, both my kids are sick tonight, and so they may pop out of their rooms for a few minutes, but hopefully it won't be there. All right, and then here we have 12 times 6. That's going to leave us a negative 12 times 6 is a negative 72. So we should get 36 92 96. Now, we're trying to get down to a single number answer. And so I see right here in our numerator, we're down to the addition and the subtraction phase. And again, I do those simply from the left to the right. 36 minus 54, let's say negative 18. I'm just going to for a quick second so we can see it. And then if we were to add 8 to that value, leave us negative 10. Numerator simplified down to negative 10, but our denominator, well, there's a little bit of commutative property here. I can see I have 2 positive 36s. Well, 36, that is 72, and it is 72. So 72 minus 72, that's just nothing. It's 0. So is this the system that gives us an answer of 0, or is this the one that gives us undefined? I always get a hard time about this. You can type it in for me, 0 or maybe a U if you think it's undefined. Good. Good. Right, so when by 0, that's when we get undefined. Yep, the solution is the way that we would say this for an equation. We're just simplifying an expression, so we'll use the phrase undefined. You can see it here. I won't make you look like horrible handwriting to spell out the whole thing. This expression comes out to give us an undefined value. Now, if it worked out to a number, a numerical value, I don't know, like negative 3, then leave that as our answer. Turns here, or are you ready to move on? Ready to try? Okay. So I'm going to open the next problem here. You guys are going to try this on your own. So as soon as I move on, we'll never be able to come back to this. So as we do these, if you have questions, you got to kind of chime as we're there. So, all right, so I'm going to turn this off and we're going to pull up the next problem. All right, so go ahead and take a minute or two here. You're going to be substituting in your negative 3 everywhere you see the value x. From operations to simplify it. When you're type, chat me the word ready, and I'll know that you're ready to go. So it looks like, take a look at this one. So as all through this, I'm just going to substitute in that value negative 3. And I like to end with parentheses. Not only does it preserve the sign, but it also preserves any multiplication if we happen to come across it in the problem. And so see negative 3 minus 6 in the numerator, and the negative 3 squared times 3. And all on our denominator. If I have 3 and I take away 6 more, it looks like our numerator will simplify to negative 9. Here we have that should leave 9. You leave that negative off, weren't you? Watch me, it's late at night. I multiply positive 4 times negative 3. So should leave me with a negative 12 and a negative 21 here. And subtracting through our values, 9 minus 12 is just going to be negative 3. And then a 21 more, a negative 24. Now, this answer, except be simplified down. First, negative, and we know negative divided by negative is positive, so we're going to get a positive answer, but it looks to me that they're both divisible by 3. Yep, they are. I think this, so I'm going to divide them. I'm going to divide both by a common factor of negative 3. And so negative 3 is just 3. And negative 24 divided by negative 3 is just 8. So we're up with a positive 3/8 this time, right? Because negative divided by negative is positive. Is that what you? Good. We'll move on this. Okay. Go ahead and turn this one off and pull up the next problem. All right, so evaluating some of these rational expressions is one thing that you'll be asked to do. But you're going to be asked to determine pieces of information about these things. And one of those is called a domain. Often it's a bit of a problem, but what I mean, anytime you're asked to find a domain of a ration, what you're really looking for is all of not in the domain of the function. And what that means, the word domain is simply discussing the values of x that we could use that real numbers for answers. And real numbers could be negative values or positive values, or big decimals, or whole numbers. But applying in rational expressions is they're not allowed to use a value of x that would make our expression become undefined. That's for situation in a rational expression. It's going to leave us undefined answer. Put in the denominator to make this undefined. Right, see, with 0 in the denominator. They want to go and answer it for us. That's right, you got to have a 0 in the denominator. I don't care what's in the numerator. The problem with I don't even remember what was in the numerator because it didn't matter. If you do 0, the whole thing's undefined. So problems that discuss domain of rational expressions, the only thing I care about is so this denominator up here, my 5, and interested in is identifying that denominator going to be equal to 0. Solve this. But this is how I always start these problems off. If they ask me for a domain of a fraction of a rational expression, I just take the denominator, add it equal to 0, and whatever equation I get out of this, I'm going to solve it. Well, the tests are you can factor it and solve it, or you can use the square root property, which is what I do. So I'm going to 25 divides on the left, and that leaves us with x squared equals 25. And then if root, I get that is equal to the and negative 5. I really have 2 answers out of this, right? Because if I were to substitute in 5 into our denominator, I would get 5 squared is 25, and 20 minus 25 is still 0. if I were to have -5, and remember when you substitute it in, you would have to substitute in with parentheses, wouldn't we get -5 squared minus 5? That is, again, 25 might still be equal to 0. So both of these answers give us a problem. They're both domain violations. Oops. And so my last point on this is that we have to include both of these as our answer. These of x that are not in the domain, both of those are problematic. And one value is separated with commas, which I did. Now, and this was I could have factored it because I could see it's a difference of squares. And I would say at 9, 10, when you're finding the domain of a rational expression like this, you're going to wind up having to factor it. Keep those factor skills handy. You're going to use them a lot in this chapter. All right, so that's how we solve this. Yeah, because I wish I knew what made it disappear like that. But at least we found a way to get it back quickly. All right, so I'll pop open a problem for you to try. It's consequence-free here. So I'm going to turn all my writing off and give you your problem. Give it a see what you come up with. Like 2 minutes here to work on that. And when you're ready, we'll take a look at them. Just send me a little chat that says you're ready to move on. Now, a little nasty of me because mine worked out with square root property, and yours, I'm making you have to factor it. Huh? A minute here for a second and look at it together. come out with some answers, you can send them through to me. Type in the numbers that you found that you think are the answers, and give me an age or not, and at least that you're ready to move on. Okay, good. All right. Asked us to find all values of x that are not in the domain. They've asked it this way. I know it's just kind of funny. It's a weird way to pose a question, but if they ask find the domain, what they'd be saying is to list every single number from near infinity to positive infinity that could be used in rational expression, and we'd be a lifetime listing all those numbers. It would be faster and easier if we just told them the one or two numbers that we can't use instead of the thousands and millions and billions of numbers that we could use. So that's why this seems a little bit of an awkward wording. So as soon as I see the word domain anywhere to the denominator becomes 0. So I off that denominator, write an equation that's set equal to 0, and then I can look at this equation and say, how can I possibly solve this? After 4, I have some factoring topics that were going on, and the very last thing that they had us do was solve quadratic equations, and that's what this is. It's a quadratic equation. It's an equation that we're going to have to use some factoring to solve. You could use a quadratic formula to solve if you were feeling particularly mathy. If you wanted, you could graph it and solve it that way. There's lots of ways to solve these. For my factoring, the safest bet, if it's a factorable polynomial, this one is. So a trinomial, 3 times. There's no in front. There's an a reverse FOIL problem to factor, which means what we're trying to do is trinomial back into a FOIL problem, because every trinomial is built of a full type multiplication. And as we said, in the FOIL process, you multiplied first times, and the only way you could get x squared as an answer is if those were x and x. So we take the leading term, that x squared, and split it into x and x. But then over and we said that we had to find the factors of a positive 72 to the term 17. And so all the possible combinations of numbers that multiply to give you 72. And you could start at 1 and 72 and 2 times 36, but I'm going to kind of jump straight to it here. And if we multiplied 8 times 9, that would multiply to give us 72. So that off this first condition, and then if I were to add these numbers together, 8 plus 9 does add up to 17. So these two numbers must be our factors, a positive 8 and a positive 9. But 8 and 9, while those are the numbers we use for our factors, they are not the answer to this equation. To the equation, you use that zero product rule, take each factor separately, and set it up. Two little baby equations that don't really pose much challenge to us. And for me at this point, I just use the opposite of what I see because I know where this is going. So I went right here and said, oh, negative 8 and negative 9 are the answers. But if you see it too, then this is the way that I would do it. And then the sums separated by commas, so we would just simply list them as negative 8, comma, negative 9. Because for domain, we pair and set it equal to 0. And then actually for solving the equation, you have to, if it's itself for square root property, great. If it's a quick, you can factor and solve. If you get that, you can use quadratic formula. If you don't like that, you can graph it. There are tools in your toolbox. And as you get further into the sequence, working towards your degree, what you'll find is that you get to these problems where they have lots of different ways to solve them. And he's going to tell you, hey, just using square root property. You just get tricks and you pull out what is comfortable for you and what you'd like to do. Any lingering questions or concerns on this before we move on? Okay, and pick out the next problem. All right, so this type of problem, we're going to actually get into working with these rationals a little bit. So things that you're going to be asked to do, and frankly, you're going to be asked to do it quite a lot, is simplify them. In purple, let's pick something green good for me. We're going to be asked to simplify these rationals. And this is another one of those things where they give you kind of this ambiguous instruction. They don't do exactly what to do. If they were being helpful, they would factor each of these trinomials and then eliminate or cancel and simplify your final answer. But at this in the game where we're at intermediate algebra, they're not going to do that. They say simplify and expect you to figure out what to do from here. Simplify a rational expression. We have to factor first, then cancel. And that's so important that I type it out up here. Factor first, then cancel. That was the rule for all of this. Not big fans of factoring. Well, if you didn't get enough practice in the last chapter, you will this time. So I see in the numerator we have a trinomial plus 11u plus 24. I'm going to copy that down here real briefly. U plus 11u plus 4. Trinomial. How we factor is determined by the number of terms we see. It's a trinomial, and there's a number in front. So this is a reverse FOIL trinomial. Term u, and factors of 24, add middle term 11. Christine, for it to disappear on me. All right, so factors of 24 that can add to 11. I've done any of these problems out ahead of time, so you'll just have to go through this with me a little bit. Sometimes I see them real quick, and sometimes I don't. I don't see it real fast. I would just start, like the first thing I was thinking in my mind was, let's try 2 times 12 is 24. Put one of them together, it gave me 14, so that didn't work. And then I up and said, well, how about 3 times 8? That gives me 4. When I add them together, I get 11. So positive 8 must be our numbers. All right, so the factoring is all you had to do, and you would have been done with your problem. In this term, it's just part of the process to get to our answer. So I'm going to rewrite this numerator in factored form. It's worth the exact same thing. I'm writing it so that it looks a little bit different. And in just a second. Let's try. Lines are getting kind of sloppy. Bam. That was like bam. Is that buddy? Emerald. And then I see a trinomial in the denominator, and at first glance I'm kind of thinking, oh great, here comes one of these AC trinomials. But in fact, if you look at all 3 of these terms, they're all the same number. We have a GCF here of 5. And if you remember how we talked about factoring, the first we do is make sure that we remove any common factors first. And that GCF goes to the outside, and the division goes inside of parentheses. So 5 divided by 5, I'm left with a u squared plus u and 8. If I make a mistake in here anywhere, you got to make sure to point it out to me. Each in a classroom, my students are notorious for just watching me work through an entire problem for 15 minutes and say, oh, shouldn't that have been a negative at the beginning? Throws the whole problem off. So let me out if you see me make a mistake. All right, so now I factored out that GCF. We've got this nice little trinomial. Leading coefficient is technically 1. This 5 is just going to stick around for our answer, but this trinomial is now a reverse FOIL trinomial. Do you see it? And I'm asking for factors of -8, just like before. Factors of, just using the sign that belongs to the term. The middle term, which was positive 7. This one is pretty quickly to me. I see -1, positive 8. Those would multiply to -8 8, but if I added them together, it would leave us with that positive 7 that we wanted. So I'll say u squared as u and u, negative 1, positive 8. We've now taken this denominator, trinomial that looked kind of ugly at the beginning, and we factored it down into its factored form, and I'll do that back up here into this denominator. So the way that it looked, it's the same amount, just looks different. And I get to, now this is usually where I get, one of those wise Alex students in the class say, what are we doing this for? Why are we bothering doing this? This is stupid. The reason why is, reason why is I can't cancel across an addition or a subtraction. And that's one to always try to do on this is they'll come in here and they'll see, let me red ink pen. Look, well, I can see that 24 and 40 are both divisible by 8. So can't I just call this 3 and call this 5? We cannot do that. And the reason why is what you're using right there to do that cancellation. But the only reason you're allowed to ever do cancellation is because division is the inverse of multiplication. Right, 24 is being added. You see that? They're adding 24. They're subtracting 40. Is division the opposite of addition? Is the subtraction? Of course not. So I cannot use a division process to eliminate these or to simplify these terms because using inverse operations, it violates some of our algebraic principles. But if my factored form, the numerator and the denominator, we do have a common factor. These u plus 8s are exactly the same. Look what's 8. These parameters is being multiplied times this u plus 8 on the denominator is being multiplied times the u minus 1. This bar is a division symbol, and division is the inverse of multiplication. And canceling these because division is the inverse of multiplication. And it leaves our final answer, a simplified fraction of u plus 3 over 5 times u minus 1. And I leave mine in factored form. I would not bother distributing the 5 back in there. All right, so recap, there's really only 2 steps to this. Factor. All of my work was in the factoring, don't you agree? I had to factor reverse FOIL, and then I had to factor this one with the GCF and reverse FOIL. But once there really math left to do except to cross out what was the same. And that's 2. Cancel. All right, so first, the cancel. So I'll pop open a new problem for you to spend a few moments on. Maybe we'll spend 3 or 4 moments on this one. And that's what you do. You're going to factor it and then cancel. First and then cancel. I see a reverse FOIL trinomial, and then we got a trinomial down here that's a little tricky, so spend a moment, look at it carefully, and let's see what we come up with. We'll come back in about 3 or 4 minutes and take a look at this. Wanda, that would I haven't worked it out all the way myself. Just working it out in my head here. That looks good. All right, some notations here. And, look at this one. So, it's trinomial in front. Well, really, we know it's a 1, right? But this tip off that we should be using reverse FOIL on this problem. You can see that I've copied it down and set up my parentheses. I know I can part my v squared into v and v. And I'm factors of the last term, 6, add to the middle term, -5. Don't caught by this one. A lot of students will try to use 6 and 1 on this, but the only way we can get here is if you have a -2, and those would multiply to the +6 and add to the -5. You just drop them in, -2 and -3. Or matter if you put the -3 first and the -2 second, it's the same thing. So that in factored form, v2 and v minus 3. And for our denominator, kind of a problem. It looks like it's set to go as a different letters right now, but for my money, if there's a common factor, I'm going to take it out. And in this case, I see they're both divisible by 4. Did you get that? So get out that common factor of 4, ECF to the outside, and my division goes on the inside. So that just leaves us with a v squared minus their embedded difference of squares. And I know split that into a FOIL problem by these 3, so splitting the 3's, 1 positive, 1. And remember GCF, he's got to stick around to your final answer. One of the most common mistakes for students in this course is to drop that guy off. Don't lonely, you got to bring him with you. And now in form, we could divide off these 6's because division is not the inverse operation of adding and subtracting, but now do it because division is the inverse operation of the multiplication that we see between these parentheses. We eliminate the v minus 3's, and here's the answer. V minus over the 4 times v plus 3. Did this one make sense to you? Just say if you got it, or I messed up on anything. Okay. All right, good. These talks right here, these are the actual phrases that you'll see in ALEKS for the topic. So if you want to go back into ALEKS and try a couple of these, you certainly can. I'd suggest it. Okay, so to the next problem here. Right along. Yeah. From my list of problems, I was feeling kind of ambitious. I don't think we'll get to them all tonight, but whatever we don't get to, we'll just kick the can down the road and we'll hit them on Sunday. So I want to go over simplifying fractions and multiplying fractions just in this format before we get into our polymers. So when I multiply, and so the first thing they want to do is just jump straight into multiplication. My money, I want to simplify as much as possible before I multiply. And so when we get into these, really I say that there's 3 steps on these. Just like before, factor first. So last multiply. This will show up to you in just a second. Steps for doing this. Now, in this case, we really don't have any factoring to do, so skip this first step, but we have any cancellation opportunities here. I don't know if you see them, but in canceling or in simplifying our fractions, because it's multiplication, it really doesn't matter which fraction number is located in, because division is with multiplication. So I don't care which fraction it's in. I can cancel diagonally, I cancel straight up and down. What is I'm looking for anything in the numerator that is greater or the same in the denominator. So that jumps out to me, yep, absolutely. Well, I can see the y's real quick right here. I see the 12 and 10 divisible by 2. So those are the things I see. Do you all see that we have an a up here in the numerator? And we also have a down in the denominator. 12 is divisible by 3. So there's lots of opportunities for cancellation here. I'll just show you the way that I like to go through these. Eliminate the y's right off the bat. There's no reason to have those things around. The a's right off the bat. We don't even need to look at them. I think I'm going to go ahead and do division here with this 3 and the 12. So when 3 goes into itself once, leaving a 1, through 12, 4 times, it leaves me with this 4. And I get to just write whatever's remaining up above it. Usually I'd do it below it if I had room. A 5 and a 10, those can do some simplifying as well. So these can start to look messy as you do them. Just kind of have to try to be organized as you go through them. 5 once, 5 into 10, and leaves us with a 2. And then I can right here, I think I'm going to go ahead and just clean this up and multiply them. You know, multiplying fractions, you can just multiply straight across the top. Numerators, I see 1 times 4 is 4. And 1 is 2. And I couldn't simplify this all the way right here for a second so that I can show you. It starts looking messy, and you're like, whoa, what's going on here? It's time to just write the equal sign and bring over what you have left. You can keep going. You don't have to do it in a single shot. Some students, they don't like to do this, and they kind of cringe at me when I do 3 or 4 cancellations in one step. If you want to do one at a time, put your equal sign and write whatever's left, that's by me. You take as many steps to do as you need to. What about it is you get down to the final answer that's 2, and you get this right on a test. So if it takes 10 steps to get there, I could care less, just as long as you get it right. Was that heard? If you're ready to move on, just chat me a little letter Y so I know we're good to move on. Ooh, thank you so much. No, I did not eliminate that Y from the 5Y. Good job. That's what I'm talking about. You got to watch me. So in reality, we had a 1Y times a 4 up here in the numerator, so we were really left with 4Y up here, weren't we? No, you did not miss that. I did. So that I make a mistake every once in every decade or something like that. So that was my mistake this 10 years. There we go. So there's our 2Y. That's what we should have left over. Thank you, Carol. All right, let's go ahead and move on. Let me give you a problem to do real quick. I don't think this will take too much time, but I just want you to get into the habit of doing simplifying. So this one's yours. Do as sling up front as you want. And as soon as you feel like you're losing track of things, just move on, put equal sign, and drag everything over. You can always get some more in a new, maybe 2 or 3 on this one. Yep, that looks good, Wanda. All right, so I think we're going to go ahead and try to tackle here so that we fit in at least one of these multiplication problems with. All right, so if I'm going to simplify this one, a couple are glaring to me right now. I see some b's both in the numerator and denominator. I also see we have 2 c's in the numerator. I have 3 c's in the denominator. I think that's where I'm going to start. These c's will eliminate these c's, and so it leaves me with a c left over. Does that make sense? And then logic, I have 2 b's, or a b squared, in the denominator. I have 5 of those in the numerator. The denominator will eliminate with 2 from the numerator. So we'll still have 3 of them left over up here on the top. 10, that's a 3. And then our 5, he's not going to help us out any, but I can see that the 4 and the 6 can both be simplified by a factor of 2. So if I divide them by 2, 4 divided by 2 leaves us with 2, and divided by 2 leaves us with 3. So it looks to me like we're going to be left with 3b cubed over 2 times is 10, and we still have so 3b cubed. So any questions there before we move on? Pop open your problem here and give you a chance at this, and then we, or was your problem, wasn't it? That's not. Let's see. Number 9. All right, open with some of these polynomials here and get started into some of the heading problems before tonight. So, remember, really 3 steps to this. I'll write them back out here again. Factors. So, if I can write. And lastly, multiply. All right, so look at our probably a little bit of factoring that we can do. Can you see it? It looks like a factor of 3 up here in our upper right, and then our denominator looks like I can factor that as reverse FOIL. So let's take care of this one first. Does everybody see we have a GCF of 3? So x plus 3. If I factor GCF of 3, we're up with a GCF of 3 on the side, and the answer to our division will become x plus 1 in parentheses. All right, so now 3 times the quantity of x plus 1. Then here in the denominator, see a trinomial. Leading coefficient is really 1. Right, that's going to become a reverse FOIL. Split my into x and x. And then I'm looking for factors of negative 2 that can add to negative. The only way to get that is if we multiply negative 2 times a positive 1. That would multiply to negative 2. And if I gather, we're still left with negative 1. So what you get, negative and positive. That is replacing this trinomial. So I'm just going to write the whole problem up here real quick. X plus 2 over x minus 2 times x plus 1 times, and now we have 3 the quantity of x1 all over x3. Doesn't look like we're going to get a lot of help out of this one. This is kind of the fun part of the problem, because we can find anything that's a factor in the numerator can cancel with a factor in the denominator. The only thing that we're going to get here are these x plus 1s were the same. Hey, let me ask you a quick question. If she wants good, can I cancel out these 3's right here? I've got a 3 here and a 3 here, a 3 in the numerator and a 3 in the denominator. Can I do this? Can I just go choop, choop? Can I cancel those out? Good. I cannot. Do not do it. For base here, I might say, why can't I do that? But I won't type out a novel for me. You cannot, because subtraction can inverse operation of a division, right? We cannot cancel across a subtraction or an addition. So I've done first step. I factored first. We canceled, and then here and I'll try multiplication. I 3 times x2, and that's just, you wouldn't leave the 3 back on the back end. And then I'm a little problem here. We've got x minus 2, x minus 3. And that, I'm going to leave that. I like factored form. Then multiplying this back out. We've got a good serve. Let's walk away from it. So you want to try here real quick. It's going to look at this, and I want you to follow 3 steps. Factor first, then, and lastly, you multiply. Get this guy pulled up for you. There's number 10. A little bit of factoring to do in this. And let's see where you're at. I think we'll take it here, and then we'll finish up with this one. When you're ready, just word that says you're ready to move on. Okay. That looks like I haven't done this one out in my head here just yet. I think you're on the right track. Just another finish up. All right, some of these can be quite involved. There's an amount of factoring in this one. And I tried to put a lot of AC method problems, those tend to take a good amount of time. But they will show up for you as well. All the types of factoring that we saw in Chapter 4 will show up in these problems. So here in my first numerator, we have a reverse FOIL problem. I'm just going to up here in the upper left. And when you paper that I've worked on, this is typically how I kind of organize these. If this was in the upper left, I factor in the upper left. If this is in the bottom left, I factor it in the bottom left. It just helps me stay visually organized for what factorization goes where. I can choose a reverse FOIL problem. I split x's. I'm looking for factors of -3. I can add +2. So it looks like I have a +3 and a negative. I'm kind of the factors in the addition component here. We've got to moving in that direction where we can factor these a little bit faster. If you spend any extra time practicing on anything, factoring is the thing to spend your time on. You've got to get really good at it and be pretty quick with it. So new numerator. So I'm just real quick. X -1. This shape up to be pretty fun at the end. The other is FOIL down here in the first denominator. I'll split my x's. Factoring -5. It looks like we're going to have a -3, -2. We already -3 in our second numerator. There's nothing that can be factored out of him, so we're just going to copy him down. And then down here on our second denominator, the bottom right, see I have a GCF, a greater than factor of 4. G to the outside. Answer our division goes on the inside. And I times the quantity x -1. And a bit of cancellation in here, so our x -3 should eliminate. Doesn't work right. And then -1s should cancel. Isn't that your heart pumping? I don't know what does. You better check yourself. And so then we get a final answer. It looks like, so we did our first step of factoring, and we got fraction, did our canceling, and then 3, we're going to multiply. So I get x plus 3. And our denominator becomes, I'm going to use our coefficient 4 times x minus 2. And put a box around them and walk away. We've got it. All right. Today covered material that comes out of Chapter 5. If you're keep track, that's Chapter 5.1 and also Section 5.2. We're going to pick up on where we're at. This is, I think we have 2 more problems to do out of 5.2, and we'll get into 5.3 stuff as well on Sunday. And what kind of time we have? Maybe we can get a little further than that. As always, I'd love to have any feedback that you have. You can email me at houstonj@seminolestate.edu. And you can always check in on our free tutoring that's in the Academic Success Center. And you can check out all of our locations and hours on our website, seminolestate.edu/academic success. If you have any lingering questions or concerns, feel free to let me know. Otherwise, guys, thanks for joining us tonight, and see you back here on Sunday. Take care. Have a good night. Wanda asking, will we cover word problems on combined variation? It's a good possibility. If we have time, it'll be towards the end. But you send me a little email saying, hey, I definitely want to cover word problems on variation. I'll make sure to stick that in there, and we'll make sure to hit one or two of those, okay? So just shoot me an email at houstonj@seminolestate.edu, and then know what I need to work in there, okay? Have a good night.